In this video, I'm going to show you how to use your calculator to answer questions with regards to the normal model. So the 68, 95, 99.7 rule is just a rough estimate, and it only works when we have questions with, the exact 1, 2, or 3 standard deviations above or below the mean. What happens when we want to talk about a value that's not one of those exact values? So this is the same question as before. I'm talking about IQ tests. I want you to notice that I've described the distribution now using that notation. So I know I'm using a normal model with a mean of 100 and a standard deviation of 16. And the question is, what percent of IQ scores are less than 110? So I have the model here. I've labeled the standard deviations, which you don't have to do. I'm showing a lot of work here because I'm explaining how to do this. But 110 is about right here, right? So this is about the value 110. And I'm asking for the percent of IQ scores that's below this. So I'm looking for this area under the curve. I want to know this percent, which I can't do using that empirical rule. So we're going to use a command in our calculator called Normalcdf, and it's under the distribution button, which is right there. So we're going to have to hit second and vars to get to this. And then we have the format here for the lower, upper bound, mean, and standard deviation. So I'm going to play the video of the calculator doing this, and I'll pause it as it goes through. So the first thing is to go to second vars, which will give you that distribution, and you're going to go down to Normalcdf and hit enter. Right here, you'll notice that you have like a negative 1e to the 99 or a 1e to the 99. That's because a normal model goes to infinity, even though negative and positive infinity. So your calculator is writing negative and positive infinity in scientific notation. Instead of trying to duplicate this, when I'm writing positive infinity, I just write a bunch of nines. Obviously, 99,999 is not infinity, but for the purposes of our graph, it's close enough. Same thing if I have a negative value, I'll just write negative 999, whatever. I'll write like 4 or 5 nines, and that will give me the negative quote-unquote infinity. So I'm going to show you how to enter these values. So with this problem here, my area here, the lower bound of my area is negative infinity, and my upper bound is this 110. My mean is 100, and my standard deviation is 16. So that's what we're going to enter in the calculator. So I'm going to change this to negative 999. Be sure to use the negative button here and not the subtraction sign. My upper value is 110, the mean is 100, and the standard deviation is 16. And then you hit paste, hit enter, and you're going to paste it. And then that will give you the answer. Now, on your homework or on an exam, you're going to show your work for this problem by writing the command and the numbers that you entered. So your work would be to write Normalcdf negative 99999 to 110 with 116. And we got an answer of 0.734, which is about 73.4%. All right, so let's do a couple more like this. So Here again, I have the same thing. I have a normal model with a mean of 100 and a standard deviation of 16. It says, for part B, it says, what percent of people have scores between 85 and 120? So 85, so right about there, and 120, right about there. So I want to know the area here. So you're going to go to the Normalcdf command. So again, remember that second vars, which is the distribution button. You're going to arrow down to Normalcdf. And this time your lower bound is going to be 85. The upper is going to be 120. The mean is 100 and the standard deviation is 16. And you will get 0.72 or 72%. For part C, it says what percent of IQ scores are above 94? So 94 is about right there. And we want all the scores, or the likelihood we're going to observe a score above 94. So again, you're going to go to second vars and distribution, and we're going to go to Normalcdf. In this case, when we look at our area, the lower is 94 and the upper is infinity. And again, I'm not going to try to type in that 1E99. I'm just going to do a bunch of nines. Seriously, sometimes I have 4 nines, sometimes I have 5, sometimes I have 6. I just type some nines. The mean is 100 and the standard deviation is 16. And you will get 0.64617, which is approximately 64.6%. So that's the Normalcdf command, but what happens if we want to go in the opposite direction? So what happens if we know the percent and we want to know instead the cutoff score that will give us that percent? So I have an example here, and again, I'm using this exact same normal model with a mean of 100 and a standard deviation of 16. And it says, what is the maximum IQ score for the lowest 2.5% of people? So remember back to when we were doing the 68, 95, 99.7% rule, and we said that the central 95% of scores were between these two standard deviations, right? This is 95% of data is between these two scores. And so we knew that then 2.5% of the data was above 2 standard deviations above the mean, and 2.5% of the data was 2 standard deviations below the mean. So right now I'm just using the empirical rule to answer this question, and I know that the answer is 68, that the lowest 2.5% of people here, the highest IQ score that encompasses that region is 68. But I don't always want to go through all of that work, and it's actually much easier to do on your calculator. The only trick here with this command is it's different if you have the newest calculator than if you have one of the older versions of this calculator. So I have a video here using the new calculator, but on the next slide, I do an example where I use one of the older calculators. So we're going to go to the same place, the distribution, which again is right here. And the inverse norm command is right below the Normalcdf command. When we enter the area that we're looking for, we have to be sure to write the area as a decimal and not a percent. So 2.5% as a decimal is 0.025. So let me run this video here. So you're going to go to second, vars, go down to number 3, which is inverse norm. The area is going to be 0.025. The mean is 100. And the standard deviation is 16. I'm going to stop it here for a second. The new calculator has this tail option. If you have one of the older calculators, this isn't here. In this problem, I'm looking for the bottom, the lowest 2.5%. So I'm looking at this area here, which means it's the left area. And so if you have one of these newer calculators, you would choose left. If you have an older Ch.5 or a Ch.83, then left is the default. Every single one of the areas is considered left, which is going to make some of the future problems a little bit harder. So for this problem here, we're entering inverse norm. So that's what I'm going to enter for my work. 0.025, 100, 16, and left. When we paste that and hit enter, we have our answer of 68.64. Now remember that what we found here was an IQ score. This is not a percent. We were finding the scores that corresponded with 2.5%. So this is the highest score that outlines the region for 2.5%. Also notice that it's not exactly 68. Remember that I said that empirical rule was an estimate. This is the more exact answer. So we would say that this is 68.64 and this is the IQ score. So this is in points, but not a percent. Oh, there we go. Okay, so this is going to be a video of the older calculator if you have it. And I'm going to do a problem where you're going to have to do a little bit of work if you have an older calculator. So again, same scenario. We've got the normal model with a mean of 100 and a standard deviation of 16. And we are looking for the minimum IQ score for the top 10%. So the top 10%, I don't quite know where that is, but we'll estimate it's right about here. So there's 10%, and we are looking for this IQ score. What is it that gives us that top 10%? So if you have the newer calculator, you're going to enter inverse norm. You're going to use 10%, but you're going to write as a decimal, so 0.10, a mean of 100, standard deviation of 16, but now the area is to the right of the curve. And when you do that, you are going to get... Oh, I didn't write that one down, so let's run the video. All right, so now the video with the older calculator. The older calculator automatically gives you the left area. But what I have drawn here is a right area. But let me change colors for a second. However, if this red part is the upper 10%, then this is the lower 90%. And it will give us the same score, right? The value that separates the top 10% also separates the bottom 90%. So for the newer calculator that automatically does left, we're going to go to inverse norm, and instead of using 10%, we're going to use 90%. And again, there's no position to write here because it's automatic. So let me run the video here. So you're still going to go to second vars, go down to inverse norm, and notice it just gives me area, mean, and standard deviation. So the area is 90%, mean is 100, and standard deviation is 16. And when I paste that, we get 120.5, which means that this was also 120.5. So the upper 10%, that score, is going to separate the upper 10% the same way it separates the bottom 90%. All right, so let's do a couple of examples. Same scenario. All right, what IQ score separates the top 20% and the bottom 80%? So again, we're looking at the top 20%. Where is that? Probably like right here. So that's 20%. We want to know this score. And then here's the bottom 80%. All right, so if you have a newer calculator, you're going to do inverse norm, 0.20, 100, 16, and you're going to choose right. If you have an older calculator, and when you do that, you will get 113.47. If you have an older calculator, you're going to do inverse norm, 0.80, 116, and you'll also get 113.47. And if you have a newer calculator, you could put 0.8, 116, and left, and you'll also get the same answer. All right, the next problem. This is where it's definitely unfair for the people who have the newer calculator. This problem is very easy, and if you have an older calculator, you have a lot more work. So this question is saying, in what interval do the middle 50% of IQ scores fall? So the middle 50%. Remember that the 68, 95, 99.7 rule said that 68%, the middle 68%, was separated by the interval from 84 to 116. The middle 95% is separated by the interval from 68 to 132, and the middle 99.7% of data is separated by the scores of 52 to 148. So we know that the middle 50% is probably somewhere in here. So there's the middle 50%. And we want to know, what are these scores? So this is the middle 50%. If you have a newer calculator, you will use 50%, the mean, the standard deviation, and you'll choose center. And when you do that, it will give you an interval of 89.2 to 110.8. But if you have the older version of this calculator, we have to do a little bit more work. So again, keep in mind the normal model is symmetric and it adds up to 100%. So if that's the middle 50%, then I know that what's above that value is 25%, and what's below this value is 25%, right? And that gives me the total 100%. So if I want to find this value right here, then that automatic left area is using 25%. So I'm going to have to use two different commands here. I'm going to find this first 89.2 by doing inverse norm using 0.25, 116, because that's the value that separates the left 25%. And that's how you'll get the 89.2. Now I want to get the next value, the upper part of this interval. And if I want the upper part of this interval, then the left area is this 50% plus the 25%, giving me a total of 75%. So with the calculator, you'll do 0.75, 116, and you'll get the 110.8. And then you'll have the interval from 89.2 to 110.8. Okay, so I'm going to do one more example where I change the scenario up and we mix up the normal CDF and inverse norm command.